Okay, so just to get a little extra practice with our definitions, I'm going to do a video claiming that the semantic equivalence of alpha and beta is the exact same as that alpha semantically entails beta and beta semantically entails alpha. If you wanted to be very careful about this, you could say that this is actually then an alternate definition for logical equivalence. You could say that this is true exactly when this is true. Okay, so how do we show this? We want to show the two directions. So we want to show that alpha is equivalent to beta. That implies alpha semantically entails beta, and beta semantically entails alpha. Okay, so let's suppose that alpha is logically equivalent to beta. Then, by the definition of by the definition of logical equivalence, alpha and beta have the same truth table. So we'll have like P, Q, R, S, and we'll have some truth table with some number of variables, and then we'll have alpha, and we'll have beta. And everywhere that there's a true in alpha, there will be a true in beta, and everywhere that there is a false in alpha, there will be a false in beta. And this will be however big it is. We don't know what alpha and beta are as general formulas. All that we know is that this property holds of them. They have the same truth table. So, do we know if alpha semantically entails beta? Or if beta semantically entails alpha? Consider an arbitrary row. So let's pick some row. And when we say pick an arbitrary row, we basically mean that there is some specific row, but we don't get to pick it. Like, if some other adversarial person is going to be like, I want to pick this row. I don't believe you. I think this row is going to be the one that's going to fail. And so they're going to pick a row. And we're going to consider an arbitrary row. I do want to keep this circled here. If alpha is true, then because it has the same truth table, since alpha and beta have the same truth table, beta will also be true. Now, because the row that we are considering is arbitrary, this is a true statement for all of the rows. Thus, every row with alpha true has beta true. And that actually means that alpha semantically entails beta. And you can do the exact same kind of argument to show that, similarly, beta semantically entails alpha. And that's part of the argument that we wanted to show. Thus, what did we want to show? We wanted to show this right here, that if we have this logical equivalence, then we have these two semantic entailments. And that's exactly what we did. We supposed the logical equivalence, and we went ahead and we deduced that beta is semantically entails alpha, and alpha semantically entails beta. So this proof, I'm not going to actually write this. This is, if you were writing a proof on homework, this would be where you would stop. But we've only proved one direction of this. We've proved this direction. If we want to actually claim that these are the same idea, then we need to show both directions. So we now need to show alpha logically entails beta, and beta logically entails alpha. That implies alpha is logically equivalent to beta. Okay, so we do the same kind of structure that we did before. Suppose that alpha semantically entails beta, and beta semantically entails alpha. That means that in the truth table, everywhere that alpha is true, beta is also true, and everywhere in the truth table that beta is true, alpha is also true. So let's sketch out what that truth table is going to look like. We'll again have P, Q, R, S, any other variables we have. And we'll have alpha, and we'll have beta. And we'll have some trues and some falses. And if we have a true in alpha, we have a true in beta. I'm going to leave that there. And if we have a true in beta, then we have a true in alpha. So we're going to consider an arbitrary row. Again, consider an arbitrary row. And let's start to think about what would be nice, because oftentimes when you're doing proofs, you want to start up with when things are convenient for you, and then figure out how to deal with the inconvenient cases that are left over at the end. So if alpha is true, then since alpha semantically entails beta, beta is true. Let's keep our notation consistent, true. Similarly, if beta is true, then since beta semantically entails alpha, alpha is true. So those are some easy cases. If neither alpha is true, nor beta is true, then the only case left is if alpha is false and beta is false, then alpha and beta have the same truth value. And so now we have either alpha is true and beta is true, or alpha is true and beta is true, or alpha is false and beta is false. So we have three cases, and in all three of the cases, alpha and beta are going to have the same truth value. So thus, this row has alpha and beta having the same truth value. So once alpha and beta have the same truth value, then that means that we're moving towards logical equivalence. The only thing left to check is that this is true of every row. But since the row is arbitrary, alpha and beta must have the same truth value on every row. Thus, alpha is semantically equivalent to beta, or logically equivalent, whichever language you prefer. And so now we have to check again, did we actually show what we wanted to show? We supposed at the top that alpha semantically entails beta, and beta semantically entails alpha. and then we wanted to show that alpha and beta were logically equivalent, and now we have shown that alpha and beta are logically equivalent. And so that is exactly what we wanted to show. And if we go way back up to the top, the very first thing that I said was true, and we're going to try to justify, it's that alpha and beta are logically equivalent if and only if alpha semantically entails beta and beta semantically entails alpha. And now we've shown that this is true. So this is actually a relatively complicated proof. This is something that we would expect that you could do by the end of the term. If you're struggling with this a little bit now, don't worry. During our next unit on proof systems, we'll cover how to make proofs, and this is the kind of proof that you might think about when you're going through that. And I think that's all I wanted to say on this section.